Hi children, in that previous video we discussed up to that properties of numbers. That is the first property, closure property we discussed, right? Okay, so that closure property on that different types of numbers also we discussed. Okay, depends on that 4 fundamental operations completed. So in this video we are going to discuss about that the next second property, that is commutative property. Okay, so what is that next one? Commutative property. Okay, commutative property on different types of numbers. So the first type of number is natural numbers, and second one whole numbers, next integers I or Z, next Q. Q means rational numbers, and here real numbers. So on these types of numbers, how to apply that commutative property, and it is easy to hold that 4 fundamental operations or not. Okay, first we will discuss about that. In commutative property, first we will discuss about that addition. Okay, first fundamental operation, addition. So before going to discuss about that addition on commutative property, what is the definition of that commutative property? Here, if you add any two numbers, if A and B are any two numbers, if you add those two numbers in any order, which means if you change the order of the numbers, then also you will get that same result. So the sum of any two numbers in any order, means here A plus B or B plus A, okay, which gives that the same result. Okay, just I taken for under that addition. Okay, according to this commutative property, here we have to apply for that subtraction, multiplication and division. So in all cases it is possible or not, we have to observe that. Okay, so let us see for that addition. So here let A comma B are any two numbers, then A star B is equals to B star A. Okay, already you know about that star, right? So here what is that formula? That is A star B is equals to B star A. Okay, so here let star be any fundamental operation, no? So at the place of star we can take that addition, subtraction, multiplication, division. So any one of that fundamental operation. Okay, so first I am going to apply that addition. We are discussing about that addition, no? So apply that addition. So here in that natural numbers, just discuss in that natural numbers. Here A is a natural number and B is a natural number. Then A plus B is equals to B plus A, where A comma B belongs to natural numbers. Okay, where A comma B belongs to natural numbers. So let us take that A is equals to some 8 and B is equals to 7. We know that 8 is a natural number and 7 is also a natural number. So if you add that 8 plus 7, what is the value of B here? That is also 7 plus 8. Just observe this condition here. This is 8 plus 7 and here 7 plus 8. Okay, I changed that order. Just we have to observe that in those two cases also we will get the same result or not. Okay, we will get that same result or not. Here 8 plus 7 is equals to 15. Okay, which is equals to 7 plus 8 also equals to 15. So here we can say that LHS is equals to RHS. So shall we say this one here? Okay, LHS means left hand side value is equals to right hand side value. Okay, so in this case it is satisfying or not? So in addition it is satisfying. So natural numbers are commutative under addition. Natural numbers are commutative under addition. So for example here these numbers related to whole numbers. Okay, here A and B belongs to whole numbers. Now what will happen? Here we can say that 8 is a whole number, 7 is a whole number, and in the same way here also 7 is a whole number, 8 is a whole number. Okay, so in this case also it is possible, no? So here also we can say that whole numbers are commutative under addition. Okay, so natural numbers possible and whole numbers also satisfying here. What about that integers? In integers also same like that only, no? If you add that any two integers, Okay, in integers I am going to take that one as, here let a is equals to -5, b is equals to -6. Two negative integers I taken here. So here what is the condition? Condition is same, no? A plus b is equals to b plus a. So a is equals to -5 and plus of b is equals to -6, which is equals to b is equals to -6 plus of a is equals to -5. Okay, after substituting that values here, -5 plus of minus is equals to -6. Okay, which is equals to -6 plus of minus is equals to -5. So -5 -6, those two numbers also having the same sign, so we have to take it as its sum only, no? So -5 -6, which is equals to -11, and here also -6 -5 is equals to -11. Okay, so in this case also we can observe that if you take any two positive integers, then also that is possible, and if you take that any two negative integers, then also that is possible. Okay, so in any case, what is the definition for that commutative property? Means if you add any two numbers in any order, if you add any two numbers in any order, then you will get the same result, then you will get that same result. So here in integers also possible. Okay, so in natural numbers possible, whole numbers possible. In these two cases that is possible, means in that remaining all cases also that is possible. Okay, for example here in that natural numbers not satisfying, whole numbers not satisfying, means we have to check for that remaining. Okay, but at starting only in natural numbers that is satisfying, means the whole numbers automatically it will be satisfied. Okay, in these two cases it will be satisfied, means automatically in that remaining three cases also, in remaining three types of numbers also it will be satisfied for any type of property. Okay, simply here you can say that rational numbers will be satisfied and real numbers also will be satisfied. Okay, so rational numbers also commutative under addition, and as well as real numbers also commutative under addition. So like that also we can say here. Okay, after that apply that subtraction. Okay, we have to discuss for that subtraction. Okay, in subtraction, how we have to write here? In natural numbers, a minus b is equals to b minus a, where a comma b belongs to natural numbers. Here the condition, again what is the definition for that commutative property under subtraction? Means if you take the difference of any two numbers in any order, if you will get the same result, then only that law satisfies. If you didn't get the same result, then it will not be satisfied. Okay, so let us check that. Here I am going to take that, let a is equals to 10 and b is equals to 8. Okay, I am going to change the order, that is 8 minus 10. Okay, so 10 minus 8 is equals to 2, which is equals to 8 minus 10. Just observe that the greatest number is having that negative sign, so the value is equals to minus 2. Okay, so the value is equals to minus 2. We are getting the same result, but here its a sign will be changed. Okay, here positive sign is there, here negative sign is there, no? So signs should be changed here. That's why sign changed also, those two are not equal. 2 and minus 2, those two are not equal, right? So that's why here 2 is not equals to minus 2. 2 is not equals to minus 2. Okay, so in this case it is not possible. In this case it is not possible. So here it is not possible. If you take that whole numbers, in whole numbers these two numbers we can consider it as whole numbers also, no? If you take that any two numbers, okay, you will not get that the same result in that LHS and RHS side related to the fundamental operation subtraction. Okay, so natural numbers not satisfying, so as well as whole numbers also will not be satisfied. Okay, actually in that previous video what we discussed, it should be satisfied means if you take in two cases, one of the greatest number and smallest number, another one smallest number greatest number. Okay, if you change that numbers, in the two cases also you will get that the same result. In two cases also it is satisfying, then only we can say that that law satisfies, that law holds. Okay, even in one case it is not satisfying, in that remaining cases also it will not be satisfied. Okay, so here I taken that positive values not satisfied. Is there any satisfaction for that negative integers? Negative integers also will not be satisfied. Okay, for in case negative integers satisfied, but here positive value is not satisfying. Okay, that's why in that integers also it will not be satisfied. Okay, as well as the remaining two also will not be satisfied. Okay, if you have any doubt, then you can check that it take that any two values. Okay, after check that one. Okay, after you completed this video, just take that just forget about this table, just you try to take that any two values and try for that each and every type of numbers and check that it is correct or not. Okay, if you have any doubt, then you can comment in that comment section. I will clarify your doubts. Okay, so under that multiplication, so here under that multiplication in natural numbers, a into b is equals to b into a. Okay, where a comma b belongs to natural numbers. A comma b belongs to natural numbers. For that closure property, just you have to observe that each and every type of number, every time we have to take the different examples and we have to show. But here easily we can say that LHS and RHS we will not get that same result under subtraction and division. Okay, I will tell you that one. Mostly we will get that same result under that addition and multiplication. Why? Because multiplication is nothing but the repeated addition. No, so that's why here which property holded by that addition, the same property will be held by that multiplication also. Come to that subtraction and division. Division means repeated subtraction. So subtraction does not hold, that's why division also does not hold. Keep that point in your brain, then easily you can fill this all. Okay, so come to that multiplication. Here I am going to take that example as 2 into 3 is equals to 3 into 2. So if you change that order, then also you will get the same result or not. For that addition we are getting, so that's why for that multiplication also we will get. So 2 3 6, which is equals to 3 2s also 6 only, no? 3 2s not equals to 9, no? 3 2s equals to 6 only. So if you change that order, if you take the multiplication, if you take the product of those two numbers, then always you will get that same result only, no? Okay, that's why here this is satisfying. Okay, and we can take that these two numbers are whole numbers also. Okay, if you take that 0 into 3 is equals to 3 into 0. Here also we will get the same result. So it is satisfying for that whole numbers also. Okay, so natural numbers are commutative under multiplication and here whole numbers are commutative under multiplication. So these two numbers holds. So as well as we can say that integers also, no? Take that any two negative integers, minus 3 into minus 2, which is equals to minus 2 into minus 3. Okay, so minus into minus is equals to plus 3 to 6. And again, minus into minus is equals to plus 2 3 6. So and in the same way, if you take that one positive integer and one negative integer, then also you will get that same result on both sides of that is equal to symbol. Okay, both sides of that is equal to symbol, we will get that same result only for that integers. So this is also will be satisfied. So integers are commutative under multiplication. So as well as these two also will be satisfied. Okay, so here we can say that rational numbers. Why? Because in that rational numbers we have that integers also. So that is satisfying, no? If you have that doubt for that rational numbers, I will show you here. For that rational numbers, if you take that a into b is equals to b into a. So I am going to take this one as 2 by 3 into 4 by 5, which is equals to 4 by 5 into 2 by 3. So in that multiplication we have to multiply that numerator by numerator, denominator by denominator, no? So 2 4s 8 and 3 5s 15, which is equals to 4 2s 8, 5 3 is 15. So here I taken the two rational numbers. So that is satisfying or not? Satisfying only, no? So that's why here these two also satisfying. So rational numbers are commutative under multiplication, as well as real numbers also. What about the real numbers? Real numbers also commutative under multiplication. Okay, and at last the final fundamental operation, that is division. Okay, come to the division. So what is the division form here under that natural numbers? A divided by B is equals to B divided by A. Then only that law satisfies here. Here I am going to take that A, B are any two natural numbers. So here let A is equals to some 10 divided by B is equals to 2. Okay, and here B is equals to 2 divided by A is equals to 10. Same values we have to apply now here. So that's why, how we can write this? 10 divided by 2, which is equals to 2 by 10. So 2 ones, 2 5s, and here 2 ones, 2 5s. So which is equals to 5 is equals to 1 by 5. Is it possible here? 5 is equals to 1 by 5. Is 5 is equals to the value of 1 by 5? Not possible, not at all possible. So that's why 5 is not equals to 1 by 5. 5 is not equals to 1 by 5. That's why here in division natural numbers will not be satisfied. Okay, not only in that natural numbers, the whole numbers also it will not be satisfied. Why? Because here if you take the reciprocal of that first fraction or that first division form, if you take its reciprocal, always you will get that its opposite value. Its opposite value means its reciprocal values only you will get. Okay, for example here you will get that 1 by 4. In that RHS you will get that its reciprocal as a 4 only. Okay, so in RHS and LHS you will get the two reciprocal values always in every case. Okay, or if you have doubt then you can check for that. Okay, just you try this one. So here also these all values not satisfies. So simply we can say that any type of numbers also will not be satisfied. Okay, will not be holds that commutative under division. Okay, does not holds that commutative property under division and subtraction. Here just which natural numbers are commutative under. Okay, this type of questions also will come. Natural numbers are commutative under. Okay, under dash. What is that? Addition, subtraction, multiplication, division. So which option is correct? Yes, addition and multiplication. Okay, two options also we can give for that. That is related to multi correct answer type. And here commutative property does not holds. Okay, does not holds natural numbers under. Commutative property does not holds natural numbers under dash. That is what here? Division and subtraction. Okay, so in these two cases it does not holds. In that addition and multiplication only it satisfies. Okay, so this is about that commutative property. So once again I am going to tell you that what is the definition of commutative property. If you change the order of that any two numbers, then you will get the same result, then only it satisfies. If you take that addition, it is satisfying, and multiplication also satisfying, but when it will not be satisfied means for that subtraction and division. Okay, so this is about that commutative property. So in this video we learned about that commutative property. In that next video we will discuss about that associative property. Okay.